motion, circuit breaker of motion. Means circuit breaker is a complex testing and operation is a complex operation, and we know how difficult and how critical this is the operation. So for that purpose, we know we need to energize the coil. Then coil will move, operate, energize the uh, coil will motor will energize the coil. Coil will move, operate the mechanism. Mechanism will operate the operating rod, and using linkage, moving contact will move and hit with fixed contact. We know these reactions. We know about this. So using our HISAC Ultima, we will check the all the parameters for operating this breaker. We will check the all parameters, whatever breaker coil current, whatever the mechanism travel, whatever the moving contacts, uh, speed, moving contacts timing, and fix on with how much time required to close the breaker, how much time required to open the breaker. That whatever the motions happening during this operation, we are measure we using our HISAC Ultima, we can measure these motions and we can monitor these motions. So this is the important. So we know the breaker components. We need to using control signals. We are operate the mechanism of the breaker, and using this some mechanical linkage, we are operating the interrupter contacts of the circuit breaker. So we know about this. There is a operating mechanism required for operate the circuit breaker. So we will see the short video of working principle of circuit breaker. Here, this is the spring is charging. So for closing operation, first spring will charge. Then after this charging, CD will operate and go to close position. It will on. So close operation will happen. During that trip, spring charging happening. Then charging will go. Then close spring will charge. So after that, this trip spring will discharge and open operation will happen. This is the open operation will happen. So this is we know about this working principle of the circuit breaker. So using HISAC Ultima, we are testing the these all parameters, whatever we see in earlier video. So testing is not finding the damages of faulty components of the circuit breaker. We are monitoring the whatever drift happening in the closing coil or coil any changes in the coil current or traveling mechanism or any changes in the timing, closing timing, opening time. So we need to monitor all these parameters, whatever parameters there, CB parameters, we need to monitor. Earlier, using our timer, using our timer, we can measure the only close timing, open timing, CO timing. Using CRM, we can check the only static contact resistance meter of contacts. Meter. Using that, we can measure only that single parameters, whatever resistance is there or any timing. But using our HISAC Ultima, we can measure the electrical timing, mechanical timing, PD of the contacts, closing coil current, tripping coil current, what is the speed of the mechanism, what is the contact travels, how much contact total travel of the moving contact and fixed contact. So this this is our product, HISAC Ultima. This is ultimate product to measure these parameters. So we are providing, this is our product. In this, we are you can see here, this is the HISAC Ultima, and this is DCRM modules for with with 6 channels. So we will see today. We will see only about the HISAC Ultima. So this is rack module based instrument. We are provided separate module for measuring the separate parameters. So first card is a CPU module. Using this module, we communicate instrument with laptop. We here we are provided the supply section for supplying the instrument. And second card is a breaker control module, which is used for control the breaker. So using this, you can operate the breaker. Close. You can operate the breaker. Third is a PRCC card, which is used for measuring the travel and coil current of the circuit breaker. Fourth card is a contact timing card, which is used for measuring the contact timings of circuit breaker. Fifth is the auxiliary card, which is used for measuring the auxiliary contacts timing of the circuit breaker. And this sixth and seventh card is used for connecting the interface the DCRM model with main model. And we are having the facility of additional measuring the DC motor current or any analog channels station coil resistance. If you want to measure the coil resistance, then you can provide the uh, right. So this is about our overview of the products. So we will see the one by one module. So CPU, in CPU module, this is the main power supply unit with 1 ampere so fuse. In that, we are providing the short circuit protection with 1 ampere fuse, and also we are providing the over voltage protection in this module. So with this, we are taking care of over voltage and over current protection of the instrument. This is the main on off switch, which is used for on the switch on the instrument. This is the master earthing connection, which is used for to protect the instruments and safety of the instrument and human also. So whenever you are taking the instrument on the site, first do the master earthing connection with grid earthing to protect the instrument and human safety. And this is the earthing port for communication purpose using Ethernet cable. You will connect the instrument with our instrument with laptop. So second card is breaker control module. We are also call it is SSR card. In that we have provided three fuses for internal protection of the internal circuitry, short circuit protection of the internal circuitry. Here we have provided uh, SSR card input for breaker control, uh, controlling the closed coil. Trip 1 and trip 2 same like this is the electronic switch to control the coil coil voltage of trip and closed coil. So this using this connection you can control the breaker. So we are using simply electronic switch. So using this we can extend the DC supply to the coil, and using that DC supply we can operate the breaker. So We are nowadays we are used this trip to connection configurable for close also. If in the case if close connection is faulty or it is not working, that time you can use trip to as a close. So we are providing the facility for that. That trip to connection you can use as a close with the help of scope engineer. We have provided hidden keys with software. So using that, you can use this trip to as a close. So any case, if you want the help, you can take the help of uh, scope engineer. They will guide you how to use the trip to as a close for testing purpose. Serve your emergency. So here simple connection is there, breaker control model. This positive will connect to the DC positive and C plus will connect to the close coil for uh, uh, operate the breaker for close operation, and this positive will connect to the DC positive, and T1 positive will connect to the trip coil. So using this, you can operate the breaker for open operation. Then the third card is a travel and coil current card. In that, we have provided travel channel and coil current measurement channel. In travel channel, we have provided 5 volt DC supply through kit to transducer. Using that transducer, we are measuring the variable re- resistance. So we will connect the variable and ground of transducer to these 2 points, and we will measure the travel of the mechanism. So with this travel mechanism, we can check the speed of the mechanism. We can check the speed of the contacts with the help of linkages. This is the coil current channels. This is the coil current channels. Here we are using simple circuitry. We are using 50 milliohm chain to measure the coil current of the circuit breakers for tripping coil and closing coil. So we are using simple circuitry. We are using simple Ohm's law for measuring the coil current. So here we are giving some connections of the coil current and connection diagrams, 5 to 6 types of connection diagrams for measuring the coil current and operate the breaker. So using this combination, you can measure the coil current of close and trip with single channel. So here for channel 1, we using channel 1, we can measure the coil current of closed coil also and open coil also. For that purpose, we require to do the connection like this. So first we connect the channel 1 positive will connect to the positive of the DC. Then channel 1 negative will connect to the positive of the breaker control module of close and trip, and C positive will connect to the close coil, and T positive will connect to the trip coil. So using this, you can test the breaker, and you will get the during open operation you will get the trip coil current here, and this is the open operation. This is typographic mistake. You can get the this is trip open timing, and this is the coil current of trip. So in second operation, if you consider second operation, then here also you can get the close coil current in same channel. So this is the connection, second connection. Using this connection, you can measure the coil current separately. For channel 1, you can use uh, measurement of closed coil, and channel 2 used for measurement of trip coil. So here is a simple connection. Channel 1 positive will connect to the DC positive. Channel 1 negative will connect to the positive of the closed SSR, and C plus will connect to the closing coil. Like that, channel 2 positive will connect to the positive, and channel 2 negative will connect to the positive of the tripping coil, and trip 1 positive will connect to the trip trip coil. So using this, you can get the graph like this. This is the CO operation. So in CO operation, first channel 1 will get the closed coil current, and channel 2 will get the trip coil current. So this is the simple. Using this, you can measure the coil current of close and open in separate channels. This is channel 3 is connection 3 is same like connection 2, but here we can short three coils, close coil, in internally we need to short these coils for trip 1 you can see here, sorry, close you can see here, and trip you can see here. So same like connection to positive will connect to the positive, negative will connect to the positive of SSR card, and C plus will connect to the close coil, and close coil will internally short for this. So using this, you will get the same result. In channel 4, here you can measure three separate coil, closing coil current in separate three channels. Here connection is simple. Positive will connect to the positive, and C plus will connect to the channel 1 positive, channel 2 positive, and channel 3 positive, and C minus will separately connected to R phase. Channel 1 C minus will separately connect to the R phase coil. C minus of channel 2 will connect to the Y phase coil, close coil. C minus of channel 3 will connect to the B phase positive. So using this in channel 1, channel 2, and channel 3, you will get the separate coil current. And for channel 4 or channel, if there is a 6 channel instrument, then you can use other 3 channels for trip coil also, separate coils. Here is the connection for trip coil also. So this is the simple connection. Using this connection, you can measure the separate coil current also for trip also and close also. Then contact timing. Fourth card is contact timing card. Using contact timing card, we have provided 24 numbers of binary inputs. Using that, we can measure the 12 main pair and 12 main timing and 12 pair timing at a time. So you can, using this card, you can test the 765 kV breaker in single uh, operation. You can measure the timing, close timing, open timing in single operation. So here we, you can check the single pole 220 kV breaker, single pole breaker is there. Then simple connection, R1 will connect to the one side of the contacts, and common will connect to the other side of contacts. And for double break pole system, R1 will connect to the other one side of contacts. Common will connect to the middle portion of the breaker, and R2 will connect to the other side of the breaker. So using this, you can measure the two break pole timing. You will get the main one contact in. You will get the timing of main one in R1 and main 2 at R2. So this is the simple connections. Then fifth is a auxiliary timing module. In auxiliary timing, we have provided 8 channel auxiliary contacts module also, and 12 channel auxiliary contact module also. Uh, Modules. Nowadays, we are configuring dry contacts and wet contacts in same card because we have R&D oriented company. We are come up with solution with dry and wet as a configure. So earlier days, we have given the separate circuitry for measuring the dry contact timing and wet contact timings, separate connection. So that we have specification for wet contacts from 24 volt to 250 volt DC. Wet contact channels, we can measure the timings of wet contacts, and dry, you can measure dry contacts at any point. So there is a connection, simple connection. You can see here, DC positive will connect to the A1 channel, and this common point will connect to the common point. So NO-NC contact, you will get the timing of NO-NC contact in A1 and A2. In dry, in same like breaker contacts timing connection, dry contacts will connect A1 to common point is there. So this is the simple connection. You know about that. And this DCRM link model is which is used for linking the DCRM model with main unit for measuring the DCRM and DCRM. Before going to the testing, we will see the some test manager software related settings, setting related options. So we know the settings. In settings, there is a you after opening the test manager software, you go to the setup menu. In setup, there is a breaker type setting, and then select the breaker type information. In breaker type information, you can type the you can select the type of the breaker, then you can select the manufacturer. If manufacturer details is not available, you can add with 1 minute. I will show the demonstration uh, like that. In breaker information type, sorry, here you if you want to add the any manufacturer, you can add the data maybe like that. You can add it. If you want set the setting voltage, you can add here and go to the next menu. Here, this is the for reference measuring reference of closing timing and opening timing. Generally, we are measuring the first closure. So time measure the measuring point of close timing is first closure. So you put here as a first close. You can select it is as a first close. For opening time reference, you can select as the last opening. Here, this is the important point, linkage ratio. It's related to linkages between mechanical movement and contact movement. So this is the linkage between contacts and mechanical. So it will provided by you put. We recommended put the linkage ratio as per OEM guideline. Then there is a this travel channel setting. It's related to datum points, datum velocity and default velocity. We know the what is the velocity. Velocity means speed of time. So whatever we need to measure the speed, na, then whatever reference we need to take two reference, for one for timing, one for uh, distance. So datum point is related to distance. So using these close one and close two points, we can measure the close datum velocity, and using open open point 1 and open point 2, you can measure the datum velocity of opening. Same like in default, reference is related to the time. So using this close uh, point, we can measure the default velocity of close section, and using this open point, you can measure the default velocity of opening. After that, this is the simple pass phase limits. You can put here limits minimum and max of circuit breaker. It's mainly for OEM. In factory test results, we are using this. So you can put your limits, min, max, whatever close minimum acceptable results you can put here, and you can select here. You can give the selection. So you will get, if results will not get in within range, then you will get the here you can see pass fail results you will get here. So like that, you can check breaker type settings. In breaker information, you can get here. You can put the breaker identification, breaker type, serial number, what which substation is there, which bay is there, operator is there, gas pressure, how much gas pressure is there, how much oil pressure is there. You can give the information about the breaker. You can put the all data about the breaker. Then most important setting is a system setting. In system setting, there is a we have provided sampling speed, different sampling speed, 1 kc, 5, 2 kc, 5 kc, 10 kc, 20 kc. For you can select the sampling speed. So for we scope recommended 5 kc, you use the sampling speed 5 kc for time measurement, and for desired measurement you put the sampling speed 10 kc. This is plot length. Using this, you can plot the results. Uh, how much results plotting results you required. You can put the plot length depend on that. Generally, in 400, you will get the all results of close, open, CO, OCO. In that, in case of PD measurement, you need to change this plot length up to 3 seconds. So in that, for that purpose, you need to change the sampling speed up to 1 kc. Here we are taking in our HISAC test manager software. We are taking 40,000 samples only. So like that, you need to change the sampling speed and plot length on that. We have limitations up to 40,000 samplings only. So depending on sampling speed and you can use the plot length. For 1 kc, you can use the plot length up to 40,000. For 10 kc, you can use the plot length up to 4,000 milliseconds only. So then there is a delay TCO. Delay TCO is a delay between close command and open command. For this is important for DCRM signature analysis, and close CO timing measurement. So generally, thumb rule says put the delete ECU for timing measurement of CO timing measurement close minus 10 millisecond. And for TCRM measurement, we put the delay TCO 300. Its power gear standards says 300 delay TCO is sufficient to measure the static uh, contact and stability of the uh, breaker during CO operation. Delay TCO is delay between O and open command and close command. So you can use as per your requirement. Command duration is nothing but how much time you require to uh, command command. So command duration is used for uh, uh, power on the switch. Whatever we earlier seen in slide, we have used the electronic switch for extending the DC voltage to the coil. This TCRM range we will see in DCRM, our DCRM, next presentation of DCRM. Then current ranges is there. There is a different type. For coil current measurement, we have provided up to ranges up to 5 kc, sorry, 25 kc, sorry, 25 ampere. So for channel wise, we have total 6. You can change the coil current ranges from 0 to 25 ampere. Using that, you can measure the coil current. Then here the velocity enable disable option is there. If you are measuring the travel, then you put this into enable option. If PR time, if you want to measure the PR time, you need to enable this option. Then if you want to measure the timing, then you need to enable auxiliary timing. Then there is a we have already seen if you want to if you are having station DC channel, analog channel, then you can enable these channels and you can test the parameters. Then most important is autoflash related option. This is related to the travel measurement, and there we have provided three types of option, but scope recommended to use this third option. Enter electrical stroke length and travel will calculate during every operation. Using this option, you don't need to do anything. You need to put only electrical strict length, and our instrument will taken care of all the calculations, internal calculations. So you will get the results properly. If you want to use the electrical stroke length and do the second option, then you need to do one additional operation, close operation for measuring the data. So we are recommending to use the third option to use the internal electrical stroke length, and travel will be calculated during every operation. So you don't need to do the settings. So we recommended use this setting only. So after doing this settings, you can perform the operation. You can perform the operation. So before perform the operation, we know how to do the connections. So first do the connections to the instrument side. First do the earthing connection to the instrument master earthing we have already discussed. Then do the connection from instrument side, and then do the connection to the breaker side. After doing that, uh, First, remove the earthing from circuit breaker and check the circuit breaker should be open condition for closing operation. Means if you want to do the closing operation, then you need to check the breaker should be in open condition. Then power on the instrument. Then establish the connection between instrument and laptop. After establishing the connection, whatever we have, whatever you want to do the standard setting, you can do it. Then use the select the proper trip channels. We have seen earlier. We have provided trip one and trip two option, additional option for operate the trip. So you can use the these trip one and trip two option. Then you perform the closing operation. So after that perform the operation, you will get the result. You can repeat the operation for other for open CO, OC operation. So after that, you will get the expected results, whatever you want. So this is the typical 765 kV closing graph. Here you can see all. This is the coil current graph of travel. Here we are use separate coil current for channel 1, channel 2, and channel 3. So here you can get this is the travel graph. This is the timing graph of 765 kV R phase, Y phase, and B phase. And this is the auxiliary timing graph of dry contact. Here you can see the typical opening graph of uh, 765 kV breaker. Here you can see the typical graph of CO. Here you can check coil current of 6 channel. Most important part is now transducer. Today's topic, our topic is related to travel measurement. So for traveling measurement, you need to do the settings of transducer. So what is transducer? You all know about the transducer. Transducer will convert one form of energy to other form. So here we are using electromechanical transducer. We are using simple register, variable register for measuring the transducer. So using our internal circuitry 5-volt supply, we are given to the transducer, and transducer will calculate the travel of the mechanism of the circuit breaker. So we have generally we have two type of transducer: linear transducer and rotary transducer. In linear transducer, resistor element is like this, and rotary transducer resistor element is like this. So whatever electrical stroke length tip of linear transducer is like this. Here mechanism can move from this point to this point. So this is the mechanical stroke length, and electrical stroke length means from this point to this point. Means electrically connectivity is of the transducer from this point to this point. So total using this we can measure the electrical uh, travel or electrical stick length of the linear transducer. So generally this is the linear transducer of for ABB net circuit breaker. Uh, we are using this, and this electrical stroke length of this transducer is 280. We have mentioned on each transducer we have mentioned in electrical stroke length. Then this is the serial transducer. we have mentioned here. You can see clearly see here we are mentioning the electrical stroke length and mechanical stroke length of transducer. For rotary, this is the rotary transducer. Rotary transducer electrical stroke length is uh, electrical stroke length is 308 degree. So we earlier we seen here. Here we see in electrical contacts of rotary transducer from 0 to 308 degree only. From this point to this point, there is a no electrical contact. There is a no resistive element. For that purpose, we are using electrical stroke length of rotary transducer is 308 degree only. So generally, we are facing the problem related to the rotary transducer settings because of this non-electrical contact. We are not getting the results properly. So we need to do the settings properly of rotary element. We will see in later slide about the rotary transducer. So we know the importance of transducers. Transducer mechanism of every breaker is different type of mechanism. So it's very difficult to us to generate the universe transducer for every breaker because mechanism of circuit breaker it changes manufacturer to manufacturer. It's not only to manufacturer to manufacturer. Also, mechanism of circuit breaker also change. Year wise also change. So we developed ourselves like that. We have developed more than 90 type of transducers for measuring the travel of circuit breaker. So it's very uh, difficult, but we have uh, R&D and we have a strong team, mechanical team for developing the transducer. So we have generated more than 90 transducers for different type of circuit breakers. This is typical design graph we travel. Here we will discuss in later next session about the detail in details. Then also I will give some idea about the mechanical travel, mechanical timing, electrical timing of the circuit breaker using this transducer travel. So, from we know mechanical movement of circuit breaker starts from this portion to this portion till time breaker will do the breaker will try to energize the coil to and try to move. So from this point to this point, it is called mechanical timing, and electrical timing is start from starting point. So this is from this point to this point, it is called electrical timing, and from this point to this point, it is called mechanical timing. So using fast mechanism, you can change the timing, or you can improve the timing of closing. You can improve the timing of opening. We will see in detail graph in DCRM about this timing type of graph. So I will skip this for this session. Okay. Apart from this, There is some questions, frequently asked questions during our conversation with customers about the uh, uh, testing of the instrument. There is some questions frequently from customer side. Laptop is not communicating with HISAC Ultima kit. So that time you first need to check. You will get this type of screen. Then you simply go to the OK and go press OK and go inside the software and first set the IP. After getting this setting the IP, na, you will connection will be established and you will get this screen. If then you can configure after setting the IP, you need to configure the instrument. So it will take 1 minute or 30 seconds. So you will get this screen. Then second problem after there is a command options are disable in condition. So this will happen due to the IP related setting or maybe the problem in timing related card. So first we recommended to do the IP setting. If IP setting also there, then also problem is there. Then you check the configure option. If configuration is failed, then there may be the problem in the timing card. So you need to uh, uh, contact to scope engineer. He will guide you how to resolve that problem. Third problem is command is not executing from HISAC Ultima kit. That time you need to check the 3 amperes slow blow fuse of SSR card. So first you check that uh, fuse. If fuse is okay, then you need to check the cable continuity, cable contacts. Then also problem is there. Then you check with multimeter with good response. You put the multimeter in diode mode and connect in between close and DC positive of breaker control connection of breaker control card and give check the respective command. And if during execution command just see the screen of the multimeter. If you see the any deflection, then there is no problem in the card. You need to check the connection of cable with terminal box. Then fourth is the close command showing continuous close strip command showing continuous means breaker will operate continuously. With that time you need to check same repeat the procedure whatever related to the uh, command. You need to put the multimeter in diode mode and connect between close and positive breaker control card and check the command section. If you if you, if you show any diode continuity, then there is a problem in the that command related option. So suppose if you got the problem in close section, so for temporary purpose or emergency purpose, you can use trip to as a close with the help of service engineer. They will guide you how to use the trip to as a close. Uh, fourth, fourth is the most important. What should be delete issue for minimum CO time operation? This is the important. Uh, point. We have already seen the thumb rule says delay TCU should be close timing minus 10 milliseconds. If then also you are not getting the CO timing, that time you can put the delay TCO 0 and command duration of team command duration should change from close timing plus 20 milliseconds. And we recommended to if you want to use measure the correct CO timing, you can discuss with OEM about the delay between close command and delay TCU. What is the exactly delay TCU of circuit breaker measuring the CO timing? Linkage ratio we have already discussed. Linkage ratio is the most important uh, of contact travel measurement. So it is a ratio between contact travel and mechanical travel. So if you want to measure the contact travel, so you should put the linkage ratio properly, because we need to check the contact wipes. So we will see in details during DCRM presentation. So it is more important. So uh, linkage ratio should be uh, given by breaker manufacturer only. So it is mentioning in CB manual. You can discuss if you not getting the any linkage ratio. You can contact to CB manufacturer. They will give you. So it is important. We will discuss in detail during design signature how important linkage ratio for contact travel measurement, how it will affect measurement of contact wire, contact insertion, total travel. So we have discussed about the electrical stroke length in case of linear and rotary transducer. About the rotary transducer, we have already discussed, because rotary transducer there is no contact from 308 degree to 360 degree. So electrical stroke length is 308 for rotary transducer. And for linear transducer, we have already mentioned in each every transducer of the supplied. In that we have mentioned in sticker. So for some breaker, some transducer for GMX transducer, electrical stroke length is 225. For ABB transducer, electrical stroke length is 280. Linear transducer for CGL make it's vary from 265 to 269, which we will put in the sticker. This is already we have discussed. Sometimes we are getting call for travel graph is reverse manner. So that time you simple change the connection of one connection ground, interchange the connection between ground and 5 volt. So you will get expected graph like this. What most important part is what is the importance and significance of the instrument arcing, because we are working in live substation. So there is a high level induction available around us. So to avoid the induction from here as well as instrument point of view is very important. So this can ensure only by connecting the instrument or to the grid. So that purpose you need to earth the instrument with grid earthing. So this is the important first. If we how to connect the earth to the instrument, then make the connection to the DUT, and for removing purpose, first remove the all DUT connection, then remove the connection from instrument side, and then remove the earthing from instrument. Uh, बंद करतो ना.
So, Tushar has covered points particularly regarding this circuit breaker operation analyzer, HISAC Ultima, and he has covered up all the points regarding this CPU unit, about SSR unit, about the travel and coil current unit, about main PR unit, contact timing unit, and about the PCR unit. So we have received many questions, particularly about the uh, measurement type. Some of the questions mentioned here, some of the questions I'm getting regularly. So particularly, first questions I'm regularly getting the why earthing is to be connected immediately to the equipment, because see, particularly we are doing the measurement of this measurement in the proximity of kilowatt. So whenever we are taking the equipment to this switch here, we have to connect the master earthing to the equipment, master earthing of the equipment to the grid earthing. So if you are connecting the master earthing to the grid earthing, then whatever the induction voltages are available, whatever the induced voltages are there, that will get suppressed our equipment to directly to the grid earthing. So it is very, very important. It is which is very important for human safety as well as equipment safety. So whenever you are taking the equipment to the switch yard, we have to connect a master earthing to a grid earthing. So this is important. I have explained about this question. Second questions I'm getting particularly, key is our SSR unit is capable to measure a coil, give a command for AC coil or DC coil. So as per the specification mentioned, that our SSR is capable to give a can operate a AC coil as well as a DC coil also from 0 to 300 volt. So and current ranges is from up to 0 to 35 ampere. We can able to extend it to 45 amperes also. In coil current, we are having a current ranges up to only 25 amperes, but we definitely we are having that facility. We can extend it to 50 ampere or 60 ampere. So that facility or that design capability we are having in our equipment. Then we are getting a questions about this at level. So what is the difference between this datum velocity and default velocity? Tushar has already explained about this importance of the datum velocity and the default velocity. So datum velocity is to be is to be the velocity to measure the point between these 2 points. So what should be the points? So as per you can take the datum velocity point from the customer. Actually, from customer to customer or from manufacturer to manufacturer and model to model, this data velocity point gets varies. So as a thumb rule, what we can able to do? So contact travel divided by 2 plus minus 20% we can able to put the data velocity point. Default velocity we can able to say it is the average velocity. So what is the default velocity? Particularly means closing the one point is the first touch of the first closes of the top contact to minus 10, 10 millisecond of that before 10 millisecond of that closing of the contact. And in the opening case, it is a opening timing first last opening to the thereafter 10 milliseconds. So this can be the default velocity, particularly for this opening. Third, an important parameter, particularly I'm getting a questions for this timing model. So if you are getting a bounces, what should do for this type of issues? So particularly as we are doing a testing in a proximity of kilowatt, we have to take care by connecting a earthing from the both side. in our one of the new equipment, we are in a phase of launching one of our product where we are having a facility of a dual grounding, dual earthing. With the dual earthing, we can able to measure the DCR and we can able to measure the timings of the circuit breaker. So if in HISAC Ultima, if we are having some bounces issue, we can able to connect one side earthing for getting the timings and checking the elimination of these bounces. But here, I would like to mention you that our equipment is capable to suppress the unwanted voltage or induction available in the system, in the circuit breaker, or the circuit breaker. So particularly here I would like to inform one more thing that in our HISAC Ultima, earlier the specification was we can able to measure the timings of the PR contact up to only 470 ohm only. Nowadays, Mr. Particularly, this is very much suitable for this AI circuit breaker. But nowadays, many GI circuit breakers are got installed, and where the PI resistance end to end is coming approximately 500 to 800 ohm. So we also increased our limit for measurement of this PI timing from 470 ohm to 1000 ohm, 1 kilo ohm. So whether you are facing the issues of measurement of the PR timings, particularly in the GIS breaker, we can able to talk to me for getting a solution. Talk to my engineer for getting a solution. Definitely, we can able to do the modification, and by providing some of the solution, we can able to resolve this issue. Uh, I already answered the questions about the data velocity point. What should be the data velocity point? Then I also answered about the data default velocity point. The one more question is there about the electrical stroke length. So electrical stroke length is the electrical current flowing through the transducer element. That is the electrical stroke length. So in where we can able to get the electrical stroke length, particularly on the transducer, this sticker, serial number sticker, it is electrical stroke length is mentioned. So you can put that electrical stroke length for a correct measurement. And if you are having a doubt about a doubt or error, if you are seems that there is error in electrical stroke, you can contact to our service engineer for exactly measurement of the electrical stroke length, and it is very much possible to measure the electrical stroke length at side itself. In particularly for this rotary transducer, electrical stroke length mentioned to be 308. We are also having add-on facilities, particularly for this measurement of the station. This is coil resistance measurement, PR resistance, and many on motor current measurement. Many things where we can have able to add in this equipment, and we are having that much facility in our equipment. Also, Tushar has mentioned about this auxiliary channel that. Initially we were giving a four main four weight contact measurement and four PR contact four weight contact measurement and four for dry contact. Weight is for a potential contact and dry is for potential free contact. Nowadays we can able to give a configurable channels, means 8 channel you can able to use for either for dry or either for wet. Okay, we're also having an extended facility up to 12 auxiliary channels measurement at a time. We can able to give that model to you. So that facility it is already available. So particularly once again, here I am mentioning that whenever you are taking the equipment to the switchyard, you have to connect the master earthing to the grid earthing for equipment and human safety. That is very much important. Okay, so this is about the HISAC Ultima and HISAC Ultima, particularly for this circuit breaker time, measurement of the timing, close timing, trip timing, and CO timing. About the coil measurement, about the travel traces. So, what is the importance of the travel traces? Travel traces, by these travel traces, we can able to measure the contact gap, arcing contact tip length, and contact wire. So, tracing the travel is a very important parameter for checking the behavior of the circuit breaker, particularly about the mechanical and directly reflecting the contact travels. So with this particularly, in this session, we have covered about this travel, what is the importance of the travels, and how we have to connect the transducer. Transducer fixing is very much important. Connect the fixture properly is also very much important. So if you are facing any issues from site itself, you have to contact our service engineer. If you are not getting any number, you can directly contact me on my mobile number. My mobile number is 7710099363, or you can write it on service@scopetnm.com for queries about this circuit breaker testing measurement. Also, with this particularly, in the next session, we'll cover detail about the DCRM measurement. What is exactly the DCRM measurement? So DCRM is the check the behavior of the circuit breaker while making and breaking. So what is that? Particularly engagement of the first PR contact, then first engagement of the arcing contact and then main contact, and then disengagement of the main contact and then arcing contact. So particularly we have to check this. So how we can able to check the behavior of the circuit breaker while making and breaking, that we'll see in the next session. Actually, I will declare the date for this DCRM session. Maybe in next week. I will declare the date. So I will let you know to all people by sending emails or by sending a messages on your WhatsApp or messages by texting it to you. So with this, I am concluding this session. If you are having any question, you can raise your hand so that we can answer to your questions.
You can also turn on your mic and ask the questions. That is also okay. Mr. Sarapati, you can put on your mic and ask the question.
Sir, good afternoon. Thank you for your wonderful presentation. Sir, we need a presentation, sir. Can you email it to register email
Yes,
IDs?
we will send a presentation to you on your email ID. So what you can able to do, you can fill the feedback form mentioned there and you put your email ID so that we'll send this presentation to you.
Okay, sir. Thank you, sir. Sir, we have both linear transducers and rotational transducers depending upon our breaker application. Linear transducer, little break is there at the end due to some loose connection while operating. So little break is there. Whether it is repairable, that we can.
Yes, what you can able to do, we can send your photos of your transducer to my WhatsApp number. My WhatsApp number is 7710099363. Either to me or either to Tushar. His last number is 370. So
Okay,
definitely we'll try to repair your transducer.
Okay, sir. Thank you, sir.
And we're having a facility to develop each and every transducer. So Tushar has mentioned already that we are having that much capability to develop the transducer for each and every circuit breaker. For any type of any new circuit breaker, we can be able to develop the transducer as per the requirement.
Good. Thank you, sir.
Yeah, thank you. Any other questions, please? I think no questions are there.
Sir, excuse me, sir.
Yeah.
Sir, what is the linkage ratio in linear transducer?
Actually, linkage ratio is the mechanism travel to contact travel. So Tushar has already mentioned that it is to be given by the transducer, the manufacturer. So by putting electrical structure, you will get it mechanism travel, and by putting a linkage ratio in the setting, you will directly get the contact travel. So for this serial linear circuit breaker, it is a 1.64 is the linkage ratio. So if you are getting a this electrical travel, mechanical travel 140, by putting this mechanism, this linkage ratio 1.64, you can get a contact travel to 230 mm.
Okay,
So
sir.
this is an example I'm giving you.
Okay, sir. Actually, we have a G circuit breaker, and in that there is a difference of the stroke is 182 mm. Actually, is 182 mm. So in that case, actually we are using the rotary transducer. So then we put the 3 linkage ratio.
Yes. See, particularly in the GU or some circuit breaker,
Yes, sir.
for a rotary movement, we have to put this linkage ratio as a 3. So electrical, this mechanical travel, you are getting approximately 58 to 60, and you have to by putting this linkage ratio 3, you are getting it is up to 180 mm contact travel. But see, particularly, we are recommending not to use this rotary transducer because if, for connecting this rotary transducer, we have to remove this on-off plate, and again during restoring this after completing the testing, many people are missing some of the connection, or many people are missing some of the putting the plates.
Yes, sir.
So it may damages the mechanism of this circuit breaker. So we are recommending to use linear transducer, which we have developed earlier as per the recommendation of the Astam and G.
Okay, sir.
Sir, I would like to ask one question.
Yes.
Can you hear, please?
Yes, yes.
Sir, can you open that setting file, that setting page?
Can you hold for a moment, please? Yeah.
Not this one. Where that plot length, your
System.
yes,
Yeah.
yes, absolutely, absolutely. Can you just explain the command duration clause?
See, particularly by default, we have to select the command duration as 100 mm. Sorry, 100 millisecond. See, particularly in earlier circuit breaker, linear spring pneumatic circuit breaker, it is taking some more time. So by default, we have to correct this. We have to put it as 100. In earlier spring pneumatic circuit breaker of ABB, the command duration is changeover of this auxiliary switch is approximately 135 milliseconds. So in that case, we have to put it to the 150 milliseconds. But nowadays, in a spring circuit breaker, if you are putting this command duration 50 or 60, that is also more than enough.
So what is the recommendation by scope? What is the
100
recommendation?
millisecond.
100 milliseconds for closing, and what will be the for the opening?
It's approximately 70 milliseconds for the opening.
70, 100 milliseconds, 100 milliseconds for the close and 70 milliseconds for the opening.
Opening.
This is the standard.
Yes. It's
Standard
not a standard,
recommendation.
it's a recommendable.
Okay. And what
Now,
is
see, particularly in this case, if ABB spring pneumatic breaker is there and changeover time is 135 milliseconds, then you have to put, means 100 is not sufficient command duration, so you have to select it to 135 or 150 milliseconds.
Sir, repeat once more.
See, particularly in earlier some spring pneumatic breaker, the changeover time, means auxiliary changeover time is approximately 135. So
Yes,
I named
yes.
some of the breaker manufacturer. So in that case, we have to put this command duration for closing is 150 milliseconds.
Okay. Okay. And sir, another thing is that please tell me regarding the delay OC time.
OC time actually, see, particularly means you can able to select any delay TOC. TOC you can miss by default, you can able to put it as 100 milliseconds. See, particularly when any issue is there and breaker is got tripped, so immediately it should get closed. Means CO timing is much more important. So CO delay is much more important, and we have to select CO delay TCO as per the recommendation given by Tushar.
CO is very clear because we generally follow.
TOC you can put by default you can select is 100 milliseconds.
And suppose by default if it is 150, then what will be the effect in the graph?
No, actually, see, particularly delay. What is the delay? Delay means, see, if it is a delay TOC, so if you are giving it open command first and then close command, so delay means that after open command, second closing command will get initiated after 150 milliseconds.
Okay.
Yeah.
Okay.
So accordingly, this is the basic thumb rule. You have to select the delay TOC or delay TCO accordingly.
Particularly for the CO operation, when we want to check the CO operation, it means TCO is important.
TCO is important.
Got it. Got it. Thank you, sir.
Thank you, sir. Any other questions? If you are having any questions apart from this session, you can contact me on my number 7710099363. Either me or to Tushar on his last number 370. You can also write to service@scopetnm.com so that we will revert back to you on your queries. Okay. So about this DCRM session, I will declare the date in the couple of days or in the next week particularly.